Good morning, IM3 students. We are going to continue 10.2, day 2 today, and we are going to continue looking at the graphing of the square root functions according to the transformations, and we're also going to be having you practice finding the equations of square roots as well as applying real-world situations to involving the square roots. So here we go, beginning the lesson, and here's a quick review of the three reference points. Remember, the reference points for a square root function are 0, 0, 1, 1, and 4, 2. And let's take a look at the first example here. So we're given the equation. We're actually giving the graph. So in the previous lesson, you're given the equation, and you're being asked to find the graph, right? So to graph it using the transformations. But we're going to go backwards today, and we're going to actually look for the equation given the graph of the function. So write the function that matches the graph using the equation given. Notice that the only thing given here is a. There is no b. So that means we are assuming that b is actually 1 because it's 1 over 1, which is going to give you 1. So we just assume that b is equal to 1 in this case, right? And here we have 2 points that are given. So in order to find the equation, we need to identify x, y, and hk. Remember I mentioned earlier that the initial point is actually hk. So we're going to label it hk here, and then we're just going to name the other point xy. So we need 2 points that are on the graph, and we will be able to obtain the equation. So here we are. We're going to enter the variables substituted with the function value. So y has a value of what in this case? So let's name the points, -1, 2, and then we have -2, -1 for hk, correct? So y is equal to 2, so we're going to substitute the points. And then a we do not know because that's what we need to solve. X is equal to -1, and then h is a -2, so it's -2. Let's write that down. And then k is -1. So here are all of the values substituted in. Let's simplify what we can. So we got negative, which is positive. -1 plus 2 gives us +1. So now we have 2 equals a times the square root of 1, which is 1. And so we don't need to write it. Oops. And we're going to have -1. Finally, this is a simple equation, which is going to add 1 to help us find that a is equal to 3. So now that we found a equals 3, we're ready to rewrite the equation g of x equals 3 times the square root of x plus 2 and then -1 in the back. So this is the general equation that created this graph. Now I need you guys to go into decimals right now, log in, and enter this equation into decimal to make sure that it gives you this graph as a function to verify that we have found the correct equation for the graph. And that's the end of the problem. We're going to practice this again, and we're given a new equation this time. And what it means is what's missing. A is missing, right? So in other words, we are assuming that a is equal to 1. So it doesn't exist in this equation. You don't see it, but it's actually 1. So we're again given the graph. So we're going to label this hk again. And let's go ahead and find the coordinate, which is 1, -1 in this case, right? And here we have the point xy. And we're going to write the coordinate. This is 1.5, comma, 0. So those are the variables, and we're going to enter them into the equation. Y is 0. So we got 0 equals square root of 1 over b. We do not know what b is. We're going to solve for it. X is given, that's 1.5. And then minus h. H is 1. So we're going to subtract 1. And then we have a k in the back, which is k is in the back by itself, which is a -1. Okay, so first we're going to actually move that k because it's by itself. So I'm going to add 1 to both sides. So we got 1 equals square root of 1 over b times 1.5 minus 1 is just 0.5. And next we're going to square both sides so we can get rid of that square root. So we got 1 squared, which is 1, equals, I'm going to multiply the 0.5 on top, so it's 0.5 over b. And then cross multiply, I have b equals 0.5, or I can write that as 1/2, since that looks a little bit better. And we are ready to write g of x equals to square root of b, which is 1 over 1/2. Well, what does that look like, guys? What's 1 over 1/2? I'm just going to change that to 2. Okay, so remember 2 is 1 over 1/2, okay? And that's x minus 1. And then don't forget we have a minus 1 in the back. So this is the complete equation that created this graph right here. So I need you guys to go into decimals again and verify that, enter this equation. You can use y equals, and then make sure that that is the graph that is being graphed, okay? So verify that right now before we move on. And now that you know how this is done, I need you guys to practice this. So let's go ahead and have you guys try this before you check the answer. So hopefully you've had a chance to try this. Let's go ahead and practice this again using the same equation. So the first point is HK, and we have the coordinate of -3, 5. And then the second is x and y, and the coordinate is -2, 2. And let's go ahead and enter the given. Again, we're going to assume that b equals 1 in this case. And so y is 2. A, we do not know. Square root of x, which is -2, minus h, that's a minus 3, guys, which is a +3. And then k is +5. And next thing we're going to do is simplify inside here. That's a 1. Square root of 1 is just going to give us 1. So 2 equals 1a plus 5 minus 5. And we got a equals -3. So we got g of x is equal to -3 square root of x plus 3 plus 5. And go ahead and use decimals right now to verify this equation and make sure that it looks like the graph. And it actually makes sense that a equals -3, guys, because we have the graph that looks like it's flipped, right? So it actually makes sense. So go ahead and make sure you verify that before we move on. And let's take a look at the real world problem dealing with the square root function. So here we have a car with good tires is on a dry road. The speed in miles per hour from which the car can stop is given by d in feet, square root of 96d. So we got the function at square root of 96d. And basically, they're giving you some points here that you need to calculate. So let's go ahead and use the calculators right now and make sure that you verify this. So square root of 96 times 20 and take the square root of that. That should give you approximately 43.8. So go ahead and verify with your calculator and then obtain the rest of it. So if you do everything, the same thing correctly, you will do 96 times 40, take square root of that. That's going to give you 62.0. And then next one, you should have 75.9, 87.6. Make sure you guys are following with your calculator. And next, we're going to graph this. What does it look like? So at 20, it's going to be 43.8, which is like about right there. And at 40, it's going to be at 62. At 60, it's going to be 75. Something like there. And then at 80, it's going to be at 87. And then at 100, it's going to be 98. So if you connect this, it should have like sort of like a square root function right here. And it should be a smooth curve. So if we just connect it there at 0, we should be at 0. So the next thing, so this is part A and part B done. We're going to go into calculate the average rates of change over the first and last interval. So if you guys recall, does anybody recall what rate of change means? It means we're actually going to be looking for the slope, right? So we're going to look for the slope for the first and the last. So let's go back to the set of data. So if you take the first set, so we're going to do the first set right here. I'm going to do the last set. Okay, so doing the first set, it's going to be 20 comma 43.8. So that's the first one right here. So we're going to actually do the math right here. So it's going to be, remember the slope, R stands for the rate of change, which is going to be change in Y over change in X. So that's 62 minus 43.8 over change in X, which is 40 minus 20. Doing the math, and you can divide it, you get approximately 0.91. Now the second is going to be the last one, which is the last interval. So I'll call this R1, and then R2, it's going to be the 98 minus 87.6. That's a 0.6 over 100 minus 80. And if you divide that, you should get about 0.52. So part C says calculate, so we just found it right here, refer to here. And then part D, explain the rate of change, what does it represent? So part D, if you notice that from the first to the last interval, the speed is actually going down, right? So the rate of change is speed, means that it goes, the rate of change goes from 0.91 to 0.52, which means the car is getting what? Slower as the distance increases. So the car is slowing down as you're traveling more. Just like maybe a person, the farther you run, the slower your speed would be. Kind of the same idea. So hopefully you get the idea of how to work with a square root function in a real world situation. So here's another one that you guys are going to try doing the same exact thing that we just did. Go ahead and start with the function, which is given by 3.86 square root of d. So here we're giving you distance here. Go ahead and figure out the rest of the numbers. 3.86 times square root of d, 1000, which gives you approximately 122.1. And then go ahead and practice that with your calculator before you write down the answers. You should be getting 172.6, 211.4, 244.1, and then 272.9. Again, I need you guys to verify these. Use a calculator, okay? And then when you graph these, you will have 1000 is going to be at 122. 2000 is going to be 172. 3000. No, a little bit off. 3000 is going to be 211, something like this. And then 4000 is 244, which is right here. And 5000 is going to be 270 something. So you should have another smooth curve representing the square root function. And again, next is you're going to calculate the rate of change over the first and last interval. So we're going to again do it over here. So for the first, it's going to be right here, and you're going to do the last one between these two. So first one, that's going to be R1, which is 172.6 minus 122.1 over 2000 minus 1000. So if you divide that, you should get 0.0505. And then R2, the last one, is going to be 272.9 minus 244.1 over 1000 again. That's 5000 minus 4000. So if you divide that, you should get 0.0288. And if you compare the two, again, for the last part, explain the rate of change, what does it represent? Again, it's less. So it's average rate is less for the last interval, which means what? The speed is getting slower. Okay? Speed is getting slower. So that's the conclusion. And that is all for this lesson, guys. And go ahead and get started with your homework assignment in Google Classroom. Have a nice day.